Now let's go to the correlation analysis of different indicators. For this, we go into the definition of correlations. So if you go to the Wikipedia, I cross-linked it here. It's a statistical relation between two random variables or two variables what we have here. And it is a statistical association, and it gives you a so-called linear dependency. We will have later look on a linear dependency. And one very, very important point. Correlation does not imply causation. Please, please, please. You are a data scientist, and your passion and your understanding of data should understand this sentence, that correlation does not imply causation. It means that one variable is not causing the effect for another variable. That you cannot say, so oil price is correlated with the stock market. Maybe I can use the oil price to predict the stock market. Maybe they are correlated, but there is no causation relationship. Okay, please remember this. Correlation does not imply causation. Let's do a correlation analysis. If I have a matrix, I can just do the correlation here. You get the correlation matrix. Let's do this. The correlation analysis always looks like this. That's a diagonal is 1. That means if you correlate your variable with yourself, you are 100% linear dependent. This is logical. And then you can read it like this. So let's go to the 1.1. If you go to the agriculture, you have a positive correlation of 8.8. Then to the next one, 9.4. That means if one value rises, the other value will also rise, maybe in a different way. And then we will have as well negative correlations. It means if one value is going up, the other will go down. Correlation matrix you should visualize to get a better view on this kind of numbers, because currently we have a 20 cross 20 correlation matrix. For this we will use now a different library, a more statistical related library. It's called Seaborn. Seaborn is really good, which is focusing on statistics itself. And the back end of nearly everything what we are doing here is so-called Matplotlib. Matplotlib is, you could say, providing all kind of functionality where Plotly and Seaborn is based on, but Matplotlib is very horrible to handle in my opinion. So either use Plotly or Seaborn. And this line here just enforces typically that you are plotting inside your notebook. We are setting some themes on the Seaborn so that we have a nice color palette, so it's really looking nice. This is just boilerplate here around, you don't need this. And then I've done a kind of masking of the diagonal. You see here already a little bit the result. The diagonal itself in a correlation matrix, it makes no sense to present both sides because they are mirrored, because the correlation of one variable looks exactly like the other way around. So you mask out this diagonal. So I have here the command only to mask out the plotting of this diagonal. And then you define the figure size. And again, with a very small command. So take the correlation matrix, you mask it out. The annotation is true. The line width is small. The square means that this here is depicted as a square, and we push in the so-called axis object of the figure. So let's do it. And we have here the year variable still in. It makes no sense. Normally we can drop the year variable. Please ignore this year variable. Okay, now we have a correlation matrix. Is there an interesting one? The air pollution is negative correlated to the cross environment. The correlation itself, so I cross-checked some of these correlations, and many of these correlations make intuitively sense. Some are really intuitive and some are a little bit counterintuitive. And there's a quite clever method also how to compare this different kind of correlation matrices. And this is an analysis, the cluster map, or here's the dendrogram. So the dendrogram is a technique of hierarchical clustering, and in fact it sorts out different columns in such a way that nearby cells or nearby analysis are really close together. So depending on a kind of distance matrix, they are resorting the different columns and bringing it closer together and say, okay, these two columns or indicators look very, very similar, and then putting it in a kind of hierarchy to the next clusters. It gives you a good understanding of a logical dependency between the indicators, and this is what we have done just right now here. This command here. We do the correlation analysis. So I filtered the neutral elements. If we don't have this one, I think it will not work. Let's see. Yeah, it still works. If you have too many missing elements, analysis will not work. But we are doing this kind of analysis. And the analysis here gives you a very funny representation of positive and negative correlation values. So how to read it? So here in the lower corner, of course, the diagonal is again more or less a 1 correlation. So it's a yellow color is a 1 correlation. And of course, that 15,111 is 100% correlated with this one. Then we see the sorting, that these two are very close to each other. And you see it as well in the color coding of the correlation itself. That means if the color coding of a correlation is very close, the eyes are very good, they can visualize it directly. They are clustered here together. And then going more into next grouping layers, and then you can see which elements are more or less independent. I've done this kind of analysis and I analyzed it quite long, if it really makes sense. And to understand this kind of analysis, also to understand the correlation analysis, does it really make sense? Is it really a linear correlation or is it not a linear correlation? And we are going back to Wikipedia just to understand the correlation itself. So if you have a slightly negative correlation, you can see it here. It's always represented by a line of one index versus the other index. And you can see that it's also not giving you the slopes. That means how strong they are related. So if one value increases, the other increases as well. So this is a one correlation, one correlation, one correlation. And it only can identify linear dependencies, like going into one direction between one variable and the other variable. And these things here, you see here that we have a clear dependency between two different variables. It's another kind of dependency, but the linear correlation would give you a 0 and would not say something about the inner dependency. So correlation is only giving you the linear correlation. And to cross-check the linear correlation, I do often a kind of grid view. A grid view is checking pairwise individual indicators in a plotting space. And here I listed again all kind of indicators. And the pair grid view, also with Seaborn, is also done very simple. I would like to compare here 4 different indicators which I was interested in. Does the results make sense or not? Are they really positive correlated or negative correlated? How do they behave? If the one value is going up, is the other value also going up? Positive correlation and the other way around. And I did a pair grid calculation and a so-called scatter plot. And the scatter plot itself results in one indicator is in one column and is plotting the other indicator in the rows. And you can see here, okay, indicator A versus indicator B, for sure it has a positive correlation here. This is an identity matrix, which means you're correlated with yourself. And you can find as well here, for example, a wonderful example for a negative correlation. One is going down and the other is going up. Yes. This kind of analysis I do quite often at the very beginning of some analysis, before I even go into a correlation analysis, just to get the feeling of the clusters itself. And it completes now this section. So you should use more or less 3 different perspectives. The pure correlation matrix. You should try to find the cluster dependencies and understand the ratios and understand, does it really make sense? So in fact, most of the time of your analysis, you infer or you have an understanding and you really cross-check if it makes sense. And then by visual inspection, you also cross-check the mathematics behind, does it really make sense? All kind of correlation analysis. I hope you enjoyed this part of the lecture, and we will see you in another section.